Welcome back to Advent of Code. Today we will solve day 5 and let's dive in. So, safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation XY means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. The ELF has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but can't figure out whether each update has the pages in the right order. Alright, so over here, as you can see, we have the rules for ordering, and over here we have these updates, right? So each line over here represents an update, and we have to order these updates according to these rules. Okay, for example, 47 must always be before 53, right? So in this case, this is valid. Okay, 75 must be before, let's see, 75 must be before 47, so this is right. Okay, and that's basically all there is to it, right? So this one, for example, is not correct because it violates the rule 9775, okay? Because 97 over here is after 75, but the rule states that 97 must be before 75, okay? Let's see. Part 1, I will get the input. Yeah, right, I forgot something. In the end, right, we have all the valid updates, okay? So from these 6 updates, we have 3 which are valid. And we have to take from each update the middle number and then sum it up. And in the end, we have to get 143. Okay. Like the day before, I want to get manual, right? So this is called a manual, all of these together. And I want to create a struct so we can call manual from, and then we put the test input here like that, right? So I want this function to parse it directly. So for that, let's create the manual, and manual should have 2 fields, rules, and I will store the rules in a tuple of U32 values, and updates, right? And updates will be in a bag of U32s. Okay, so we have 2 fields, one storing the rules in a vector of tuples, so because we have 2 values in each line, we can store them in a tuple, right? And for updates, as before, we store each row in a vector and each column in the inner vector, right? Like that. So then let's do the parsing. Again, we convert from a string, so we implement the from trait, and the input will be a string, and we return self. So the first thing is the whole manual. We will store that in a vector of strings, right? So first of all, we have to split these 2 parts, right? We want to split this and this, right? So we have a vector holding 2 strings. The first string is the rules and the second string is the updates. So we have to split on this empty line. We can do that by using input.split, and then we can here define on which character we want to split. So we want to split over here on the double new line, right? We have over here a new line and here a new line. Like that, and then we collect. And rules and updates. So we take manual, and the first element is the rules and the second element is the updates, right? First element, second element. Then for the rules, we want to parse that into a vec of U32, U32. So rules, and we iterate over the lines, and then for each rule we split, right? So we get parts. So we have a vec of U32, and over here we split on this symbol here, right? So for each line we split on this symbol, so we get we have two elements for each line, right? For each iteration. And then we do a filter map, because we also have to parse the numbers, right? So parse, okay, then we collect that, right? So this is the inner vector, and we have to collect it into the outer vector as well, right? Like this. And of course I forgot over here to return from the map function, from the map method, parts and parts 2, right? So we have splitted, we have parsed each number, and then we return in a tuple the first and the second element, right? And then we collect it into a vector of tuples. Then let's do the updates. This will be a vec of U32, right? Updates, lines, map, and for each update we take the update, we split it, and the updates we will split on the commas, right? Like that. And then again filter map, because we want to parse the numbers. I guess we don't even need the turbofish, but I will see. Then in the end we collect again. So this will be the inner vector, and this will be the outer one. Let me see if this is actually necessary here. I don't think so. Yeah. Okay, and then self, rules, and updates, our two fields. That's it. So we can call this from a function on a string on the input, and we get a perfectly parsed manual. Okay? All right. Next step is we take the manual, we go into the updates field, right? The updates are these over here, and we iterate over them. And then filter. So for each update, and I had a question, why do I use in filter this reference and in map not? It's simply because this is the method signature of filter, right? So as you can see in this closure, it expects an ampersand, a reference. So we have to do that. And we call manual is correct order, and we pass the update, okay? And we will implement this method in a second. So we iterate over each line and pass it to this function is correct order or method. And then for each update we take the middle of the vector, right? So we call the length method and divide by 2, and then we add it to the sum, right? Like that. And then in the end we just return sum, and sum. Okay, like that. So we have to create this like this. Okay, now the only thing we need to do is we have to implement this method. And yeah, let's implement that. And as you can see, we just iterate over all of these updates, then we filter, and this method will only return the correct updates, right? That's why we have filter, and then for each correct update, we add it to the sum, the middle of the correct update, right? So some of them have 5 elements, some of them have 3, and we just have to sum up the middle value. Okay, manual, and let's create the method is correct order. Take a reference to self and update. Be like u32, and we return a boolean, right? Because the filter method expects a boolean. Okay, then what we can do is we create a filter map. I want actually to show you what I will be doing now. So as you can see over here, we have the rules, we have the updates, and now I want to create a hash map. Okay, so we take this update, for example, and then we want a hash map of the values and the index, right? So 75 is at index 0, 47 is at index 1, and so on, right? And I will show you why this is important. So let's create a hash map, u32 and usize for the index, update. We iterate, we enumerate, so we get the indexes, and then we get back the index and page. Okay, so in the text it said one single element in a update is called a page. That's why I called it page, right? And we return a tuple with the page, with the element and the index, right? Then we can collect that into the hash map. All right, I have to import hash map like this, because now what we can do is we iterate over the rules dot iter, and we can check. So the rules are tuple, and then we match So what we do over here is let me take that actually. Let me put it over here so we can see what I did. This is code. Let's do it right like that. So this is our code, right? So what did we do? We have these rules and we iterate over all these rules, and then in each iteration we get back a tuple, right? Because we have parsed them as tuples, all of them. And then we get, or we access some of the members in the hash map. So for example, in the first iteration we have 47 and 53. So we get 47, and this will be 1, right, in the hash map. So when we access 47, the hash map will return 1. And y will be 53, right? So we check, we use the get method, 53 will return 3, okay? And then, because get will return a sum, an option type, we have to dereference that. And then we check, is x smaller than y, right? Because we know that this has to be before that, so the index has to be smaller, right? So 47 would be 1 and 53 would be 3, right? So it is smaller. That is true. Okay? And that's why this will then return true, okay, in the first iteration. And we iterate over every single rule over here, right? And every single rule has to be correct, okay? Because we are using here all, meaning all of them have to return true. Otherwise, the update is invalid, okay? That's what we are looking for. And over here, we are returning true because if there is no rule for a certain number, then it will automatically be true because we don't care. The ordering is not important, right? And yeah. And that's basically it, right? So we can check if this is correct. Cargo solve 5 millis. 143. This is correct. Let's submit. Oh, sorry, I forgot to remove the test again. This happens a lot. Alright, let's submit. That's the right answer. Alright, so part 2. So for each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. So, as you remember, we had 6 updates we have to prove. 3 of them were valid. That means these 3 are invalid. And we have to basically reorder them so they apply to the rules that are set. Okay, after taking only the incorrectly ordered updates and ordering them correctly, their middle page numbers are 47, 29 and 47. Okay, again we have to take the middle number of the newly ordered updates and sum it up. Okay, so let's see. So I will take again the input. This. Right. So what we do in the beginning is actually quite the same. We parse the input, right? And again, let's have a sum variable. Then we can again iterate over the updates. And this time for each update, right? So in the manual, we call isCorrectOrder, the same function as before, and we check update. But this time, remember, we have to only check for the invalid updates. Okay, so as you remember, this method over here, isCorrectOrder, returns a boolean. So if we had So if we had updates which are false, then it will return to the filter, right? So we deny that. So if it returns false, we make it true, right? So we only concentrate on the invalid updates. And then again, for each update, we have to sort, right? So we call manual sort incorrect update, and we do update clone. And again, sorted update length divided by 2. This is just so we can index into the middle value. Sorted update mid. Okay. Then we add it to sum. And yeah, sum. Like that. Okay. And now all we have to do is just implementing this sort incorrect update. Again, we take the updates, we iterate over it, and we filter for the incorrect updates, right? The invalid ones, using the same method like we did before, but inverting it. And for each update, we sort the incorrect update, store it over here, and then just take the value in the middle. As you remember, an update is a bag of U32 values. Okay, so sort incorrect update self, and we add over here a vector of U32, basically a single update, a line in the updates field of our manual, right? And then it's actually not that big of a deal. We take update, sort by x, y, okay, and then if self root contains x and y, then it's standard comp ordering less, right? If it contains else if self rules contains yx, stand greater, otherwise it's just equal. Okay, and then over here we return update, and then we have the sorted update. Okay, now I will explain what this over here is. So let me clean up here a little bit. Let's take an update which is wrong, like this one. Okay, so 61, 13, and 29. All right, so x and y are basically the first one and the second one. So we then compare, right? We check, does self.rule contains x and y? So we check 61 and 13. This is over here. So 61 is before 13, so this is correct. If we want x to be before y, then we order by less, okay? Less is -1. An ordering where a compared value is less than another, right? So this is the ordering that we are caring about. So in the example, you can see 1 comparing 2 will return ordering less. 1, 1 equal and 2, 1 greater. Okay? And then it will stay like that. And then it will check x and y. So 13 will be x and 29 will be y. Let's see. This is not here, but let's see. 13. 29. As you can see, we have over here, we search for x and y, but it's in this order, y and x, right? So 29 has to be before 13. And that's why we use here greater, because as you can see, we check if the rules contain y and x instead of x and y, which is the case over here, right? We have here y, x. So it will reorder 61, 29, and 13, right? And that's, I guess, what 61, 13, 29 becomes 61, 29, 13, right? So we do that for every single invalid update, which we are sending over here to this method. And then we get back the sorted update, and we just take the middle value. In this case, it would be 29, and we sum it up with the other invalid middle value, right? And let's see. We have to take here a test. I'll solve is 123. All right, then I can delete this test input. Okay, and let's submit. All right, we did it. See you next time.